In this first lesson of chapter 4, we are going to focus on writing equations in slope-intercept form. And so just a quick review, slope-intercept form is our favorite, y equals mx plus b. It's the one you're probably most familiar with and most likely our favorite for most of the situations that involve linear relationships. Now I know we've already talked about slope-intercept form in the previous chapter, but our focus there was primarily graphing this. So our main objective was to understand how to graph slope-intercept form, especially using the y-intercept and using the slope of the line to kind of move from one point to the next. In this lesson, we're going to focus less on the actual physical graphing and more in how to generate or write the slope-intercept form equation given different levels of information. So we'll start off really easy, like if we're given the slope and the y-intercept straight out, being given m and b, how to write it from that all the way to being given input outputs of functions and being able to take that information and create the equation from that. So it's all about writing y equals mx plus b from different levels of information, basically. Okay, and we'll start with the nice, easy ones, the simpler ones, right? We're going to write the equation of the line given the following characteristics. And we're going to focus, again, on writing it in slope-intercept form. So these first couple are pretty nice because there's two criteria, right? So there's two criteria to writing an equation in slope-intercept form. At any given time, if I want to write something in slope-intercept form, I am going to need to know the slope, and I'm going to need to know the y-intercept. Okay, if I don't have them, I'll have to come up with ways to find them, right? But if they give them to me, then we're ready to go as long as we know how to put it into the formula that we're in business, right? So no matter what information you're given here, eventually this is what we'll need. We'll need the slope and the y-intercept if we want to be able to write an equation in y equals mx plus b slope-intercept form. So like number one should start to feel really exciting, like, well, that's good news because they gave me the slope. If they tell me the slope is -3, they basically just gave me the value of m. And if they tell me that the y-intercept is 7, well, that's the value of b. So if I'm trying to write something in slope-intercept form, these are the two things I need. I need the slope m and the y-intercept b. That is exactly what they gave me. As long as I insert those numbers in the correct location, I am able to write my equation, really quickly and easily here. So this equation would then be y equals -3x, -3x plus 7, right? So make sure that this is nice and sharp. All right, so nice and easy. Same thing here. If they tell me the slope is 2, right away I say, okay, they gave me the slope. I know that's going to go in for m. And then they gave us the y-intercept -3. That's going to be the value of b. So if I want to write something in slope-intercept form, as long as I can insert those exactly where they're supposed to go, I know that my slope always goes attached to x. I know my y-intercept is always by itself after that, addition or subtraction. That is all I need to make sure that I am careful about, and then that's it. There's our equation in slope-intercept form. So that's pretty easy because it kind of handed us exactly the ingredients we needed, right, to make this cake. They gave it to us on a silver platter. It's pretty hard to mess that up. As long as you put in the value of m with the x and then the b value after that, it's pretty easy. We didn't have to really do any work to find either one of these, right? So our attention is really going to be more focused on when we actually have to do some work to find, when we're not just handed these on a silver platter, but we have to do some work to find them. So let's look at number 3. It's a little bit of a step up. They tell me on number 3 that the slope is 4, so that's great. They still gave me m. That's my slope. But then they gave me the y-intercept. Instead, they told me that the line passes through the point 2, 6. Okay? Here's the important part to remember. I still need b. Okay? They might not have given it to me, but I still need it. I have to find a way to find it. Okay? So let's talk about what we know. Well, we know that the slope is 4. And we know that our equation passes through the point 2, 6. And what I want to remind you is that that is basically giving us an x coordinate and a y coordinate that I know are on the line. Okay? I know that that x and that y are on the line. So I want to be able to write something in slope-intercept like this. And here's how you're going to do that. You already know m, so that's half the battle is done. And then what we're going to do is we're going to borrow this x coordinate and that y, and we're going to insert them here into our ordered pair, right? So we're basically saying, hey, let's think about what we know. We know the slope of the line is 4. And we also know that when x was 2, so I'm going to replace x with 2 here, okay? When we know that when x was 2, the y output ended up being 6, right? So we know the slope is 4, and we know that when we inserted a 2 for x, the output, the final solution, ended up being 6. And because I'm able to borrow that point and plug that in for x and y, at least temporarily, that gives me enough information here so that now we can solve for b and find out what is the y-intercept for this equation. So I do 4 times 2 is 8. So let's simplify first. Now we're just solving for b. They didn't give me b, so this time I had to solve for it. And then we get it by itself by moving the a to the other side. And so we get b on this side, and 6 and a negative 8 is a negative 2. So they didn't hand it to us, but we were able to calculate what b was. So now we know b has to be negative 2. That's our y-intercept. And now we can write the final equation. When we write the final equation, we're not going to use that point, right? Our final equation in slope-intercept form always leaves the x and the y as variables unless we're specifically trying to solve for a specific point, right? So this was a borrowed point. It helped me find the information that I needed, but I don't need it in my answer. My answer is going to go back to being y equals our slope of 4. And then the y-intercept we now know is negative 2. And so that's the equation that meets this criteria, that has a slope of 4 and that when x is 2. And you could test it. If you plug in a 2 and you solve all of this, you should get 6. So we know that this is the equation that has a slope of 4 and passes through the point 2, 6. It would be the equation y equals 4x minus 2. Okay, let's try it again. Let's look at number 4. So on number 4, you're given the slope, but you're not given the y-intercept. They instead gave us a point, an xy ordered pair that we can borrow to use and solve for b. Because guys, we'll still always need the slope and the y-intercept. These are the 2 ingredients we'll always need to write that equation, right? So let's try it here. So we're going to write it in slope-intercept form. Let's fill in what we know. We know that the slope is negative 1/3, and we know that when x was 1, this output came out to be a negative 2. All right. So we fill in everything we have. That lets us have only b left that we can solve for. And negative 1/3 times 1 is still just negative 1/3. Okay. And then to get rid of this and isolate b, I'll do the opposite of that, which is a positive 1/3. There it is. That cancels. So b is going to equal negative 2 plus 1/3. Well, those are different signs, so I actually find the difference between them. And that difference is a negative 5/3. Okay. You could also write that as a fraction, sorry, as a mixed number. If you'd like, or you can leave it improper, right? But that's our value of b. And now we can write our equation. When we go back to writing our equation, we dump this point. That was just a sample point we borrowed. We're going to go back to having y equals the slope of negative 1/3. And now we know that the y-intercept is at negative 5/3, and that's the equation of this line. Okay, so if you're given the slope, great. If you have another point, you can borrow that point so you can solve for b. Okay, all right. Let's talk about writing the equation of a line in slope-intercept form if what you're given is just a graph or perhaps a couple of points from a graph, right? So remember, I'm going to keep saying this throughout this whole lesson. There are two ingredients we're going to need. We're going to need the slope and we're going to need the y-intercept. The good news is we have a graph in front of us that's going to guide us. Okay, I could use these points and use the slope formula, but because I have a graph, I can also capitalize on using this graph to help me do that, right? So if we look at the graph, I can already tell this is a falling line, a downward slope. Before I do anything else, I'm just going to say, you know what, let me just get that out of the way. I know this is going to be negative. That'll help me not forget that later. It's definitely a negative slope. It's going downward. Okay, now let's talk about rise over run. If I go from this point to that point, I'm going to talk about how much I moved. So I would have to go 1, 2, 3, 4. So I have to go down 4 units and over 1 unit. So my rise run is 4 over 1, or in other words, just 4. Okay, you could write negative 4 over 1 or just 4. Okay, then B is the y-intercept. So that is a location where our line is intersecting this y-axis. It is where x is 0. So this is the B value right there. That's B. The y-intercept is at -1. That is where my line intersects the y-axis. Okay, and once I have those ingredients, easy peasy. We just plug them in to slope-intercept form, and there's the equation of this line. Okay, so I would say pause the video here, try 6 and 7, and then see if you got them right. Okay, and if you did that already, let's see what happens. Go ahead and check your... Okay, so check your answers for number 6 and 7. And let's see. Let's see. Can y'all see that? There you go. All right, so on number 6, you have a rise of 4 and a run of 2. So 4 over 2 is a slope of 2. And your y-intercept was at 0. So y equals 2x is our equation. You could write y equals 2x plus 0, but that's kind of redundant. If it's 0, we typically don't bother writing it. Number 7, you had a rise of 2 over 2. Well, 2 over 2 is 1, so you have a slope of 1, and the y-intercept is at 1. So both your slope and your y-intercept are positive 1. So if you did those well, then you're on track so far. And let's go on then to the next page where things get a little bit more interesting, because sometimes we're not even given the slope, right? Now, we know we have the tools to find it, and that's the good news, right? But this is a little bit more realistic, where we might be trying to find the equation of a line from just 2 points that are not a y-intercept, and we still need those ingredients. So the big thing to remember here is, even if they're not originally handed to us, guys, the name of the game is we still need the slope, and we still need the y-intercept, okay? So let's start with slope. That's always an easier place to start. From 2 points, right? Could we find the slope? Well, of course the answer is yes, right? We know that we have that handy-dandy slope formula, which I'm going to write up here to remind you. So the slope formula, anytime you have 2 points, you can find the slope formula by finding the change in your y's over the change in your x's, like that, right? So you can assign one of these points as your point 1. You can assign one of these points as your point 2. And then you can use the slope formula and find what m is. Okay, so let's start there. If we start with the slope, I'm going to do the difference in my y value. So that's going to be 4 minus, and then the other y value is a -1. So when I do minus a -1, it becomes +1. That's in my top part. On the bottom, it's going to be x2, which is 8, minus x1, which in this case is 3. And let's evaluate that. 4 plus 1 is 5. 8 minus 3 is 5. 5 over 5 is 1. And we just solved for the slope of this line. This line has a slope of 1, okay? That takes care of one of our requirements. The other requirement is the y-intercept. Well, we actually already did this on the front page. We just figured out on the front page that if we know the slope and we have a point that passes through the line, we can borrow that point and solve for b. So we're going to do this one like we did numbers 3 and 4 on the previous page, right? So if we look at 3 and 4, the same way that we borrowed that ordered pair, plugged it in, and used it to solve for b, that's exactly what we're going to do now because we already know the slope. Okay, so now we'll go into y equals mx plus b, and we'll use this slope that we just found, and we'll borrow one of these points. Does it matter which one we plug in? The answer is absolutely not. That's the point. Both of these points are on our line, so both of these points should work. Okay, it shouldn't matter at all which one you pick. In fact, I'm going to pick the second one, the 8 and 4, but I'm going to encourage maybe some of y'all to pick the other one, and we should still get the same answer, which is kind of neat. Okay, so I'm going to pick the second point. I'm going to say, hey, the slope is 1, and also when x was 8, the y output was 4. So I'm going to borrow that x equals 8 and y equals 4 ordered pair right here. Okay, and then I'm just going to solve for b. So 1 times 8 is still 8. And then to solve for the b, we take the 8 away, and I get -4 as the y-intercept. And so now I have m and I have b. I have the slope and the y-intercept. I have the 2 ingredients that I needed, and I can write my equation. So our equation would be y equals x minus 4, or 1x minus 4 if you really feel the desire to put the 1 in front of the x, because that's your slope. Okay, but we know it's implied there. If I just write x, we know that's 1x. Okay, let's try the next one. Let's try one more together. Again, they didn't give us the slope or the y-intercept, so we're going to use the slope formula to find the slope, and then we'll use the technique from before of borrowing a point to then solve for the y-intercept. So let's try number 9. I'll make this my first point. I'll make that my second point, and I'll plug that into the slope formula. So y2 minus y1 over x2 minus x1 is 5 minus 1, which is 4, over 3 minus 2, which is 1, and that simplifies to 4. So our slope for number 9 is 4. And now that I'm aware of that, I can use that to plug in to the slope-intercept form equation, and the slope is 4, and we're going to borrow one of those 2 points. Doesn't matter which one you plug in. We're going to plug in a 2. I'm going to pick the first one. I'm going to plug in x equals 2, and I know that when x was 2, the output was 1, and I can solve for b. So 4 times 2 is 8. Subtract 8 from both sides to isolate the variable, and you get -7 is equal to b. And there's our second ingredient. We have slope, we have y-intercept. Can we write an equation? Absolutely. You're going to have y equals 4x minus 7. This would be the linear equation for the line that these 2 different points pass through. So try number 10, and then you're going to check it. So on number 10, check your slope. If you got 1/4 for your slope, then things are looking good, regardless of what order you did. As long as you put the y's on top and you're consistent in your order. I did 3 minus 2 and then 4 minus 0. I got a slope of 1/4. Now the reason I stopped here is because hopefully if you're kind of alert and kind of paying attention to the points you're given, I've been saying, hey, they didn't give us the slope or the y-intercept. Not so much here. If you catch it, they actually did give you. Now, they didn't say b equals 2, but if you realize that, the y-intercept is the y-coordinate when x is 0, they did give you b right in here. So we know the slope is 1/4, and actually we don't have to work for it. We see right here that b is equal to 2, because it is one of the points they gave us was the y-intercept. Now if you didn't catch that and you grabbed one of these and you plugged it in, you still got b equals 2. If you did it right, you'll still get b equals 2. You just probably did a little more extra work than you needed. If you had caught that it was one of the points already provided, then you didn't have to do that work like this, and you could just go jump right into your equation. So that was good. Okay, let's talk about number 11 through 13, because these guys look a little bit intimidating, but the reality is they are absolutely 100% the same type of problem as what you have up here. Okay, so what we were given on numbers 8, 9, and 10 were 2 points that are on the line. I know this might look a little bit different, but this is still 2 points on the line. Okay, so just remember that f of x is equal to y. And what that tells me is that when I see f of 6, that's telling me that x is 6. And when I see that f of 6 equals -2, that's telling us that the y output is -2. So when I see f of 6 equals -2, I want to realize that all they did just now is give me an ordered pair. Is tell me that when x was an input of 6, y output was -2. Okay, so that's all that's saying. It's really giving me exactly the same information. If I see f of 4 equals -3, all that's telling me is that when x is 4, the y output is -3. So if it helps, just literally rewrite that function notation as ordered pairs, and now you're back to doing problems exactly like 8, 9, and 10. Okay, all you are really being given, even though it's in function notation, is an input and an output that are paired up together. It's just a point on your line. Okay, and if you realize that, then the rest of it is exactly the same. Okay, we're going to find the slope since they didn't give us that. So we're going to do the difference in our y values. So I'm going to do -3 minus a -2 becomes positive, and 4 minus the 6. And then when I simplify that, I'm going to get a -1 over 2, or -1/2. Oh, sorry, -2. So +1/2. Ooh, glad I caught that. Okay, so I get a -1 over a -2, which is just a +1 over 2. There's the slope of the line. And then I will write my y equals mx plus b equation. I'm going to borrow one of those two. It doesn't really matter which one you pick. I'm going to pick that second one. I'm going to say y is -3, slope is 1/2, x is 4, and that gives me enough ingredients for us to solve for the b y-intercept. So 1/2 of 4 is 2. And then when I get rid of the 2 by subtraction, -3 and -2 is -5. So b, the y-intercept, is -5, and now I can write my function, right? Instead of y equals mx plus b, since they use function notation, I think it's more appropriate for us to write this with f of x equals instead of y equals, but that's just a technicality. That's just me being super amazing and formal. So try it out. The equation itself is still the same. All I'm doing is, instead of saying y equals 1/2 x minus 5, which was our slope and our y-intercept, I'm just writing f of x equals 1/2 x minus 5. We know that f of x and y are the same. So, but they used function notation, so I think it's more appropriate for us to use function notation here. Okay. All right, let's try this next one. Again, if they give you that f of -5 is 5, all they've told you is that when x is -5, your output is 5. When we say f of 5 is 15, they're telling us that when x is 5, the output is 15. So they're giving us 2 points. Let's find the slope. So the change in our y's, I'm going to do 15 minus 5. And in our x's, x is 5 minus a negative becomes a positive. Okay, so when we do that, 15 minus 5 is 10. 5 plus 5 is also 10. When I divide those, I get a slope of 1. And then I can borrow that. I can use that m value of 1 and borrow one of these points. So let's see, I'll pick that second one and say, all right, well, my output was 15 when I plugged in a 5, so my slope is 1, and I can solve for b. So there's m, and then I know when x was 5, the output was 15, and that gives me enough information to solve for b. And then we solve for b until it's fully isolated, and I get that the y-intercept is 10. So we had a slope of 1 and a y-intercept of 10, and my function can be f of x equals 1x, or x, and then plus 10, which is our y-intercept. All right, try this last one on your own, and then you can check it in just a moment. All right, so check this one out. See how you did. F of 8 equals -3 is just the ordered pair 8, comma, -3. F of 9 equals -4 is just the ordered pair 9 is -4. We use the slope formula and do y2 minus y1 and x2 minus x1. And I got a slope of -1, so check that first. Then I used that slope and one of the ordered pairs. I inserted that x and that y. I borrowed it for a moment so we could solve for b. And I got that b is +5. So then our function is f of x equals -1, because -1x basically, because that's our slope, which I'm just going to write as -x plus 5, which was our y-intercept. So there's that. Okay. There it is. Okay. All right. So if we feel good about writing those, then let's just finish out with some word problems. Okay. Let's talk about writing linear models. So a linear model, I'm doing this one. So a linear model is a linear function that models a real life situation. So when a quantity changes at a constant rate with respect to the quantity x, right? So when something is increasing or decreasing at a constant rate, you can use that y equals mx plus b model, to represent the relationship. M is still the constant rate of change, which on our graph will be the slope. B is going to be the initial starting quantity or value, which is then going to be the y-intercept when we graph it. So let's take a look at what that's going to look like here. So number 14, in the year 2000, the average cost of college tuition in the United States was about $14,000. In 2010, the cost was about $18,000. So we want to write a linear model that represents the cost of tuition as a function of the number of years since the year 2000. So that's actually really important. Okay, so when we start thinking about how we're going to set up our ordered pairs, I want you to understand that our input or our independent variable is going to be number of years since the year 2000. So it's not just the year number, but how many years have passed since the year 2000. So this is really important right here, because what that means is that this data point in the year 2000, that's essentially our starting value. Okay, so in the year 2000, we had 0 years since the year 2000 because it was the year 2000. That's kind of where we're starting. Okay, so we're going to use essentially an x value of 0 here, and at that point, the cost was $14,000. So if I'm thinking of this in terms of ordered pairs, that ordered pair right there would be, okay, at the beginning in the year 2000, the cost of college was $14,000. Okay. Then in the year 2010, the cost was $18,000. So this second point, how many years have passed since the year 2000? If we're in the year 2010, well, 10 years have passed. So that would be the x value that I would use here. So my other point is that 10 years after 2000, the cost had been up to $18,000. So those are the two ordered pairs. And once we have two ordered pairs, we can really go back to what we were doing up here, right? To write our linear model, because we have 2 points, okay? So let's use our slope formula to find the rate of change, right? So the change in our outputs, if we went from $14,000 to $18,000, what was the change in the cost? Well, 18,000 minus 14,000, that is a $4,000 change. Okay, and what was the change in years from 2000 to 2010? Well, 10 minus 0 is just 10. So it changed $4,000 over 10 years, or in other words, $400 per year. Okay, that's our slope. And then, of course, the other ingredient we need is the y-intercept. Do we know the y-intercept? Is it one of the points that were given? Yes, it is. This was our initial starting quantity, right? So B is the initial starting value. So when we started measuring this or collecting this data in the year 2000, the initial tuition was $14,000. So that is our y-intercept. And now we have our two ingredients, and we can write our function. Notice they use the word function. That's why I'm using f of x. So f of x equals 400x plus 14,000. It means we are starting with a tuition of 14,000, and every year it increased on average $400 every year. Okay, so that's our function for part A. And then if you check out part B here, it says use your model, which is this right here, our linear model, to predict the cost in the year 2020. So just be careful. We're not going to go throwing in a 2020 in here, because that would be really a long time from now. Remember, X represents the number of years since the year 2000. So how many years have passed since the year 2000? If we're in 2020, well, 20 years, right? So for this problem, we want to make X 20 and use our linear model here to predict what is going to be the tuition, the average tuition cost. Okay, so all I have to do is take my function and solve it for f of 20. I'm using 20 as my input and finding out what would be the output. So we plug in the 20 for our input. 400 times 20 is 8,000. And then if we add those together, it turns out that is 22,000. So f of 20, let me catch up here on this side, is equal to 22,000. So tuition will be, so the average tuition will be $22,000 in 2020. Oop, can barely write that. There he goes. Okay, so the average tuition will be $22,000 in the year 2020. Okay, so that's using our linear model to predict real life situations. Okay, so let's take a look at number 15. It says an electrician charges $120 after 2 hours of work and $190 after 4 hours of work. We want to write a linear model that represents the total cost as a function of the number of hours worked. So again, let's take that information and see if we can come up with some data points, some ordered pairs, right? So we've got a couple of corresponding information. We know that, we know that how much they charge is going to depend on number of hours. So that really makes this our independent, or our X value, and then what we charge is the dependent, or the Y value. Okay, and those two go together, so we can write them as an ordered pair. We can say we know that when the electrician works 2 hours, the cost is $120, and then we can do the same thing here. For 4 hours of work, the charge was $90. So the other ordered pair that we have is that 4 hours of work ends up having a charge of $190. So that gives us a couple of ordered pairs. If you're able to kind of, extract that information and set it up as two corresponding data points, right? Two corresponding values, then the rest of it becomes like the problems we were doing just a few minutes ago. As soon as you can come up with those two ordered pairs, the rest of it is just deja vu, right? It's like, oh, I've done this before. Let's find the slope. Okay, so let's find the change in our Y values over the change in our X values. 190 minus 120, that is an increase of 70 over, and then 4 minus 2 is 2. So if we divide that, it looks like the rate is $35 per hour. And that's going to be our slope. So our slope is 35. Then we can go to the equation itself, y equals mx plus b, and insert that slope in either one of our points. So we know that the rate that the electrician is charging is $35 per hour. We also know that, for example, when the electrician worked for 2 hours, the output was 120. And that gives us enough information to solve for the y-intercept, or the initial quantity. There must be some other initial quantity, because even though we know this is the rate of change and that they're charging $35 an hour, we know that 35 times 2 is not 120. So there must be some other charge or fee that's being established. That's what we're finding here, okay? So let's do that. 35 times 2 is 70. And then if we subtract that 70, the difference is 50, and that is that y-intercept. But in the context of this problem, you know, it really means like an initial fee, or, you know, some initial charge that is given. So our function for the number of hours worked is 35H, so $35 an hour, plus that $50 y-intercept, that $50 initial fee. So what is the electrician's initial fee? The initial fee is $50. If we write that as a sentence, we can say her initial fee is $50. Okay. How much does the electrician charge per hour? We can say she charges $35 per hour, right? So there's our initial quantity and our rate of change. All right, let's take a look at the very last one here. The graph shows the cost of a smartphone plan. What is the y-intercept of the line? And interpret the y-intercept in the context of this situation. And then approximate the slope and interpret the slope in the context of this situation. And lastly, we want to write an equation that represents the cost as a function of data usage. So let's start with, what is the y-intercept? So here we're working off a graph. That makes it a little nice. I can see that my y-intercept is, of course, where my graph intersects the y-axis, which it looks like it's right here at 20. So our y-intercept is at 20, or you can write it even better if you write it like this as an ordered pair. Okay, we talked about that a couple of days ago. You know, it's more accurate, or you're less likely to make mistakes if you write it like this. And in front, you know, that's our y-intercept. To interpret it, I want to talk about what does that mean in this context. Well, it's our cost that we have to pay per month when our data usage is 0. So think about that ordered pair, right? Again, the ordered pair helps. So when the data usage is 0, the cost is $20 per month. So it sounds kind of like what we did just now up here, that's kind of an initial cost or fee that is charged before they even start to add the data that you've used, right? So we could think of that as an initial cost, maybe to have the plan. Okay, so it's initial cost or fee for having the plan without including any data charges. Okay, so it's that initial cost or fee that they charge you before they add in any or include any data charges, right? And then let's talk about the slope. We're going to approximate the slope. So for that, we're going to want a couple of points. We already know the y-intercept is 20, so that's an easy one to start using. Let's see if we can find another point that seems to land pretty nicely. I'm going to go with this one right here. It looks like it really does land nicely on an ordered pair that I can read. The other ones seem a little bit off, and then I'd be estimating. Here I think it lands pretty nicely on an ordered pair that I can read. So that other ordered pair is 2,000 for the x coordinate, so 2,000 megabytes, and the cost for that is 80. Okay, so that gives me 2 points, and when I have 2 points, I can definitely find the slope because I can use the slope formula. So let's see the change in our y values over the change in our x values. 80 minus 20 is 60 over 2,000. And if I divide that out, it comes out to 3/100ths, or probably 3 cents, right? So if we are going to interpret what does this slope or rate mean, that is my rate of how much it costs per megabyte, right? So because it's y over x, so that is the change in my cost per megabyte of data usage. So I might say the data costs $0.03 per megabyte. Okay, that would be the interpretation. And then write an equation that represents the function, the cost of as a function of the data usage. Well, I have a slope, I have a y-intercept. I can write an equation. My output is going to be my slope plus our y-intercept. So we start off at $20 charge, and it increases basically 3 cents per megabyte from their equation. So that's all about writing equations in slope-intercept form from different levels of data that has been provided. Whether it's two-ordered pairs, it's a word problem, it's a graph, you have all the different options.